Hello viewers, welcome back. In today's video, I'm going to teach you how to calculate the volume of base required to neutralize a given concentration of acid in volumetric analysis. I am Amos Kumagbe. You can subscribe to my YouTube channel Amos T Online Class, follow me on TikTok Amos T Online Class, and of course on Facebook Amos T Online Class and Amos T Kumagbe. In today's video, we're solving a past question from JAM 2019. And the question says, in the reaction between sodium hydroxide and sulfuric acid solutions, what volume of 0.5 molar sodium hydroxide would exactly neutralize 10 cubic cm of 1.25 molar sulfuric acid? We have some possible options: A, which says 5 cubic cm, B, 10 cubic cm, C, 20 cubic cm, D, 25 cubic cm, and E, 50 cubic cm. Now, the first step to providing solution to this kind of problem is to write a balanced chemical equation. Now, from the question, they said there is a reaction between sodium hydroxide, which is a base, and sulfuric acid. Now, this kind of reaction is a neutralization reaction between a base, sodium hydroxide, and an acid, sulfuric acid. Now, let's see what happens. Now we have sulfuric acid, which is in aqueous form, reacting with sodium hydroxide, which is also in aqueous form, and this will produce sodium sulfate, which is a salt, and of course water. So we have sodium sulfate, which is a salt, and water, which is in liquid form. But this chemical equation is not balanced. They have to make sure that this equation is balanced. Now I'm going to enumerate the individual elements in the compounds. Of course, we have sulfuric acid, which has hydrogen, sulfur, and oxygen. We have sodium hydroxide, which has sodium, oxygen, and hydrogen. Of course, we have sodium sulfate, which has sodium, sulfur, and oxygen, and water, which has hydrogen and oxygen. So I'm going to enumerate the individual elements in the compound. So the first element is sulfur. I'm starting with sulfur because it has just a single atom in the compound. So we're going to start with the simplest one. Now let's begin. Now, from the reactant side, in sulfuric acid, we have one atom of sulfur, and of course, from the product side, we also have one atom of sulfur in sodium sulfate. So, sulfur is balanced because there is one atom of sulfur from the reactant side and one atom of sulfur from the product side. So, sulfur is balanced. We're done with that. Now, let's go to sodium. Let's go to sodium. From the reactant side, we have sodium hydroxide, one atom of sodium in sodium hydroxide, and of course we have two atoms of sodium in sodium sulfate. So sodium is not balanced because there are two atoms of sodium from the product side, whereas from the reactant side we have one atom of sodium, so it's not balanced. How do we do that? We're going to introduce two. In sodium hydroxide. So we now have two atoms of sodium in sodium hydroxide and two atoms of sodium in sodium sulfate. So sodium is balanced both from the reactant side and from the product side. So sodium is balanced. We're done with that. So let's go to hydrogen. Now we have two atoms of hydrogen in sulfuric acid, and of course two atoms of hydrogen in sodium hydroxide, because these two here is affecting the hydrogen. So 2 times 1 is T2. So we have 2 plus 2 we have 4. So there are 4 atoms of hydrogen from the reactant side. So let's check the number of atoms of hydrogen from the product side. So now from the product side, we have 4 atoms of hydrogen. We have 4 atoms, from the product side now, we have 2 atoms of hydrogen in water. We have 2 atoms of hydrogen in water. So hydrogen is not balanced. So we're going to introduce 2. We're going to introduce 2 here. So 2 times 2 will give us 4. So we have 4 atoms of hydrogen from the product side and 4 atoms of hydrogen from the reactant side. So hydrogen is balanced. Hydrogen is balanced. Now let's check for oxygen. 4 atoms of oxygen in sulfuric acid and 2 atoms of oxygen in sodium hydroxide. So we have 6 atoms of oxygen from the reactant side. 6 atoms of oxygen from the reactant side. Now let's check for the product side. We have 4 atoms of oxygen in sodium sulfate here. So we have 4 plus 2 will give us 6. So oxygen is balanced because there are 6 atoms of oxygen from the reactant side and 6 atoms of oxygen from the product side. So oxygen is balanced. So this is the balanced chemical equation representing the reaction between sulfuric acid and sodium hydroxide. Now, in this balanced chemical equation, we can see that 1 mole sulfuric acid to react with 2 mole sodium hydroxide to yield 1 mole sodium sulfate and 2 molecules of water. So this equation is balanced. This chemical equation is balanced. So that is the first step to solve this kind of question. So we're done with that. So I'm going to introduce a key formula in volumetric analysis. The formula says CA/VA divided by CB/VB is equal to NA divided by NB. Okay, so what then is CA? What then is VA? I'm going to explain. Now, CA is the concentration of acid, VA is the volume of acid, CB is the concentration of base, VB is the volume of base, and NA divided by NB is the ratio of acid to base. That is the mole ratio of acid to base. And I'm going to explain. Now, Ca, I said, is the concentration of acid. Ca is the concentration of acid. Now, from the question, it says, the reaction between sodium hydroxide and sulfuric acid solutions, what volume of 0.5 molar sodium hydroxide would exactly neutralize 10 cubic cm of 1.25 molar sulfuric acid? So the concentration of sulfuric acid from the question is 1.25 molar. Of course, the volume of acid from the question is 10 cubic cm. Now, CB, which is the concentration of base, from the question is 0.5 molar. And VB is unknown. This is what we're looking for, VB, because the question says, in the reaction between sodium hydroxide and sulfuric acid solution, what volume of 0.5 molar sodium hydroxide? So we're looking for the volume of base that will neutralize 10 cubic cm of sulfuric acid or 0.5 molar sulfuric acid. 1.25 molar sulfuric acid. Now NaNB is the ratio of acid to base, that is the mole ratio of acid to base, and this can be gotten from the balanced chemical equation. Now from this chemical equation, I've said that we can say that 1 mole sulfuric acid will react with 2 molecules or 2 mole sodium hydroxide to yield 1 mole sodium sulfate and 2 moles of water. So the acid to base ratio is 1:2. 1:2. It's 1:2 because there is 1 mole of sulfuric acid reacting with 2 mole of sodium hydroxide, which is a base. So the acid to base ratio is equal to 1:2. So we're done with that. Now let's put in the values to find, remember that we're finding Vp, which is the volume of base that is required to neutralize the acid. So let's put in the formula to find our Vp. So we have CaVa divided by CbVp is equal to 1:2, which is the mole ratio of acid to base. So how do we find our Vp? We're looking for Vp. So how do we find Vp? Very simple, by cross multiplication of this equation. So once we cross multiply, we're going to make Vp the subject of the formula, and from that we put in our values. So CbVp, that is Cb times Vp times 1, by cross multiplication of this equation, we still give us CbVp. And we have CaVa times 2. So that is it. Now we are looking for Vp, and how do we make Vp the subject of the formula? It's still very simple. We're going to divide both sides by Cp. We're going to divide this side by Cp, and we're also going to divide this side by Cp. So once we divide this side by Cp, Cb will cancel Cp, and we'll be left with Vp. So our Vp will be equal to So our Vb is equal to 2 times Ca times Va divided by Cb, and that is it. So we're going to put in the values now. Our Ca, we have 2 times. Our Ca is equal to 1.25 molar. Our Va is equal to 10 cubic cm. And our Cb, that is the concentration of base, is equal to 0.5 molar. We have 50 cubic cm, and that is our final answer. So now let's check the options. Option A says 5 cubic cm, B says 10 cubic cm, C says 20 cubic cm, D says 25 cubic cm, and E says 50 cubic cm. So 50 cubic cm, which is option E, is the correct option. This is the correct option. And this question is coming from JAM 2019, question 5. JAM 2019, question 5. And we have succeeded in finding the volume of base that will be required to neutralize 10 cubic cm of 1.25 molar sulfuric acid. If you're interested in this kind of videos, don't forget to like and share. Also subscribe to my YouTube channel, MST Online Class. Follow me on TikTok, MST Online Class, and of course on Facebook, MST Online Class and MST Magwe. Thank you for watching, and God bless you. See you in the next video.